Hi, my name is Anton, and this video is one video from a series about comparing edge platforms for computer vision. In a series of these videos, I compare platform not only in terms of performance, but also from the side of convenience and simplicity for development. One video, one platform. All videos are available on my channel, and at the link in the description you can find a final table with different boards and the article about choosing logic for comparison. Today I want to talk about Raspberry Pi. Right now I have the Raspberry Pi 3B in my hands, but everything I'm going to say is similar to the Raspberry Pi 4 and some different Raspberry Pi that you can find on the market. For Raspberry Pi 4, the CPU performance is several times better, of course. But it doesn't matter because they use the same software. And before I go any further, I must say that I of course like Raspberry Pi. In last 8 years we have accumulated a lot of experience in computer vision development on Raspberry Pi. In 2014 we created the Raspberry Pi based hand vision recognition project for one of our customers. In 2015 we did our license plate recognition project on Raspberry Pi. In 2017 I built a small bird feeder at my window to detect and create Raspberry Pi based system to detect which bird came to this feeder. In 2020 I made a Raspberry Pi based system that sent me a notification that my son was awake. And we have a lot of different projects that I didn't mention, so I might be a little biased because I think Raspberry Pi is good. This story will consist from 3 parts. In the first part, I evaluate Raspberry Pi on a number of criteria that I think are important for machine vision boards. In the second part, I will tell you about different way to develop on this board, and I think this will be most interesting part of this video because Raspberry Pi have a lot of different ways to develop computer vision on it. And in the third part I say something that didn't fall into the formal structure of first 2 parts. Let's start. How easy Raspberry Pi is for flashing. And Raspberry Pi is a standard in the industry. It has its own application that downloads and writes the selected firmware on the SD card. And there are a lot of different options that you can choose, like x64 or x32 firmware. And there are many third-party vendors of firmware for Raspberry Pi because everything is open source. How easy to work? Raspberry Pi is a platform that's supported by all sides. It's very easy to work with, but there is one problem. There are too many options, and there is no guarantee that one of them will lead you to the result. So sometimes you need to switch on different way of development, and this is both plus and minus, because sometimes you need to stop, choose different way, and there is always a way that will lead you to the result, but sometimes this way will be a little not the straight one. Okay, so 4.5 or 5 stars. How conventional is Linux? And the Linux for Raspberry Pi is super conventional. There are many different builds, and almost every of them are open sourced, and almost every time you can install any software or build it for Raspberry Pi. Community support. I think the community support is maximum from all the board for computer vision. And I don't know any other platform with more support from a huge community. So Raspberry Pi is very easy to develop and very easy to fix bug that you will have. Let's move to the models for computer vision. Efficient model zoo. And this term is a bit inapplicable for Raspberry Pi. Raspberry Pi has no official way to work. You can use the official model zoo from TensorFlow or from ONNX, but there is no universal path. And for the lack of this universal path, I will take half a point off for and only 4.5 stars. Unofficial model zoo. And there is no question here because all models are unofficial and you can start almost every one of them on Raspberry Pi very easily. And 5 stars here. Easy to convert random models. You can use about 7 or 10 different framework on Raspberry Pi. So it's very easy to convert your model in some of them. Probably it will be hard for ONNX, but it will be easy for example, TouchScript. And you can convert almost every model, and it's easier than any other board, so 5 stars. Easy to debug problems with conversion. It's easy because there is no easiest way for the debugging, because you can use same conversion tools and the best conversion tools on the market. 5 stars. Now, let's talk about how is Raspberry Pi good for real product. Processor speed. Even the Raspberry Pi 3 is faster than most boards for computer vision on the market. And I am not mentioning Raspberry Pi 4. Take a look at my table with a few different boards. Raspberry Pi much better in terms of processor performance. But unlike Coral and Hades, the Raspberry Pi has the neural network running on CPU. And this makes the overall performance less, of course. But if you need to proceed frame once every couple of seconds and do some math the rest of the time, it can work very well. So I will give Raspberry Pi 5 star just for the processor, but consider this problem because this 5 star can turn into 1 star when you need a high performance on neural networks. Mechanical parts and different construction. The original Raspberry Pi boards is not great in terms of mechanic. Of course, Raspberry Pi 3 doesn't have cooler and it's pretty good, but it doesn't have stable connectors, for example, and the heatsink is not great. But with Raspberry Pi, you can use a lot of customization options. A lot of products on the market that different boxes, different coolers, different heatsink. You can customize your Raspberry Pi. And don't forget that Raspberry Pi have a lot of different boards. For example, Raspberry Pi compute boards. And there are a lot of carrier boards for Raspberry Pi compute board. And you can create your own device that will fit your needs. So let it be 4.5 star. Easy to buy. If you have a local electronics component market, usually you can buy Raspberry Pi there. I don't know any other platform that's so easy to buy. Pins for external connectors, and of course Raspberry Pi is the reference in these terms. A lot of opportunity to use them, and you can check a lot of projects where people use them and how people use them. Speed test. Let's move on the most interesting part of this comparison, and it's speed test for computer vision. And here you can see that Raspberry Pi has a lot of possibilities. In this table, I have evaluated several ways of inference through ONNX runtime, through TensorFlow Lite runtime, OpenCV runtime, and CNN runtime, TouchScript. I will speak more about inference methods a bit later in my second part of this video. What can I say about this table? There is no universally good inference system for Raspberry Pi. The speed is unstable. Sometimes one inference system better than another. You doesn't have good converted neural network for different inference systems. For example, int8 quantization doesn't work good on ONNX runtime, and so on. But in terms of performance, Raspberry Pi is much weaker than specialized platform for executing neural networks. It doesn't have NPU chip or good GPU chip. Of course, for some tasks, this speed is enough. And of course, if you will use Raspberry Pi 4, the speed will 2 times or even 3 times better than Raspberry Pi. And I hope it's good. You can look at full table in the description when you can compare Raspberry Pi with different boards. So take a look and decide which board in terms of speed is best for you. Second part of this video. Let's talk about development pipeline for computer vision in Raspberry Pi. And there are so many ways to develop on it. Let's look at most of them. Few general ideas at the start. If you don't want to have troubles with building libraries or installing them, just use the x64 version of operation system. I used Raspbian OS in this test, and probably this is the best and easiest way for computer vision. I used FP32 neural network representation usually, but feel free to experiment with this. You can use int8 quantization on TouchScript, and you can look some samples in my table that it will allow you to increase inference speed, of course. But probably some inference systems will have problems with inference in int8 quantization, for example, in Unix runtime. I only tested Python inference. Many inference frameworks provide inference in C++. For example, all inference frameworks that I put here can be used with C++. But I tested only Python binding. Here is the 5 different frameworks that I tested: Unix runtime, TensorFlow Lite runtime, OpenCV runtime for neural networks, NCNN runtime, and TouchScript with PyTorch Python library. I also tried to test at MNN and Tengen, but I have some problems with building these frameworks, and honestly I didn't ever try to overcome this problem and decided not to test them in this video. But with all different frameworks, Unix, TensorFlow Lite, OpenCV, NCNN, and TouchScript, there was no problem with installation. Probably the hardest one is OpenCV, because you need to install additional libraries before you install in OpenCV. Everything else is pip install, and everything else works out of the box. I don't know which one of them are easier to use, because all of them can be used with just few lines of code. For example, here you can see how to run Unix classification sample. Here you can see how to run TensorFlow Lite inference. Here you can see how to run TouchScript. Here you can see how run NCNN, but the model initialization in different Python files, so there are a bit of code in that file. And also you can see how to run initialization and how to run neural network in OpenCV library. If you have a detection task, the post-processing might be a bit more code, and of course for pre-processing, probably you will need just 1 or 2 lines. Sometime probably you will need a bit bigger pre-processing, but it will depend not on framework but on neural networks that you are using and which frameworks you are using to open images. And for all of these frameworks you can find a lot of ready-made examples in the internet, and it's very easy to start with all of them. I will not recommend you any of this framework for your project because you need to choose it yourself, but for me Unix inference look like more stable and predictable in terms of model conversion and stable speed on Raspberry Pi. NCNN look like it's fastest framework, but I'm not sure about how stable is conversion because I never convert a lot of models into NCNN. And of course TouchScript looks pretty promising, but probably it will have some problems with FP32 inference because it looks a bit slow, and I'm not sure that you will find a lot of samples how to use it, but probably it's just because I didn't have enough experience in it. Let's move to the final parts where I speak about some ideas about platform and summarizing everything from above. I like Raspberry Pi, and it's a good board for many computer vision tasks. But don't overestimate it. It's not a good platform for neural network inference, of course. You can find Rockchip board with NPU unit or other boards for the same price, but that will give you a lot more performance for neural networks. But if your problem requires just a little convolutional neural networks, and you can proceed just 1 or 2 images per second, and you will have a lot of some math in your project, like 3D math, or some hard statistic or something else, then Raspberry Pi might be a very good board for you, because the processor is very powerful. Neural network will have a good speed, and they will pretty easy to run on Raspberry Pi. So in some situation, probably Raspberry Pi most easier way to use your computer vision. Thank you for watching, and keep in mind that I have reviews on different computer vision boards on my channel. Bye!